Okay, hello guys. So welcome to our lesson. So last lesson we already learned about the rotation volume, right? So now let's back to our area here. So we're just discussing about for the region between the curve and y-axis, okay? So you can find here in this picture we have x equals to fy, okay? And we want to find the area between y equals to a and y equals to b, and to find exactly what is the area here. So over here, we can just use the equation like integration from a to b, fy dy, okay? That is how we calculate here. So also you can just consider like here that this is the a rectangle. You can just consider that this area is combined with a lot of the rectangle and their areas make a sum together. That is our final area here, okay? So for this kind of the area, we can set that just using y, you can just focusing on I to say this, okay, to solve this, all of this, okay. So also remember that because here the area always becomes the x times the dy, right? The dy means a very tiny change of the y value, right? Okay, so here is dy. And for this, you can say, oh, maybe for here, we can say that integration from a, b, f, y or x dy, right? That is our exactly area, but x can also be considered as x is fy. So it can be considered as from a to b, fy dy, okay? That is it, fy dy. So for this, you can just add a modulus here, and then try to calculate what exactly the value is, okay? That is it. So here, let's have an example. Like for this problem is that x equals to y minus 4 squared, and trying to find what is the area between the straight line and the curve. So for this problem, you can first trying to set like here, just calculating for the, maybe here is for x dy, right? Just consider like this is a, maybe here that is for I guess is a rectangle, right? And the rectangles here is for x, right? Here is for x. And exactly this is dy, right? But you can find there's a little bit difference. But x at this point, in fact, it represented for this kind of rectangle, right? This is dy, and this is this point x, right? So in fact, we're not calculating the shaded area, but we are only calculating the wide area. Okay, so x dy, and also we can just say this like fy dy. Okay. So if we have x equals to y minus 4 squared, we can just put x equals to y minus 4 squared into it. They will become from 3 to 5, right? From 3 to 5. Like here is for y minus 4 squared dy. So just expand the equation, it will be integration 3 to 5 and y squared minus 8y plus 16 dy, right? That is it. And then you can calculate here is for 1/3 y cubed minus for 4y squared plus 16y from 3 to 5, right? Okay. So also remember for this equation that is a white area is not a shaded area, right? So just calculate it here. That is for 1 cubed times 125 minus 4 times 5 squared is 25 and plus 16 times 5, right? That is for x when y equals to 5. And then minus when y equals 3, that is for 1/3 times 3 cubed is 27, right? Minus 4 times 3 squared is for 9, and plus 16 times 3, right? So just calculate here is for 125 over 3 minus 27 over 3 minus 100 plus 36 and plus 80 minus 48, right? Okay, so just calculate the first part. Like that is for 98 over 3, I guess, right? 98 over 3. Yep, 98 over 3, right? And plus 36 plus 80 is plus 116, right? So you 16. 16 minus 48 is minus 32, right? So just calculate here is 3. That 8 minus 96 is 2 over 3. That is the wide area. If you call it the shaded area, you just using the rectangle's area to minus the wide area, right? So here is a rectangle's area. That is for 2 times 1 equals to 2. We're just using 2 minus 2 over 3 is for 4 over 3, right? So we can say that the shaded area in this graph is for 4 over 3, okay? That is it. So here it is. And also there's two lines here. So if you want to calculate the area between the red line and the blue line, red curve and the blue line, you can first draw a vertical line here. So then you can just using the black area bounded by the y equals 2x minus x squared, then minus the green triangle's area, right? You can just consider like this is for green triangle, okay? Just using black area minus green area means that the area bounded by the two curve right here, right? So we can set here, just using the area, we can set integration between the 2x minus x squared and here's x, right? So this can be considered as that is for the like here is pink area, right? Pink area minus yellow area, right? Okay, that is equation here. So just using two kind of integration you can calculate. And you'll also find surprisingly that this answer also equals to from 0 to 1 just using the y2 that is the upper bound like 2x minus x squared minus the lower bound is y1. So it's y2 minus y1 dx, okay? So that can be considered from 0 to 1 x squared minus x cubed over 3 that is dx, okay? So you can calculate the exact area here, okay? And also for these examples, you can also use this method to solve this. For example, like here we have some intercept, like it intercept with y equals 5 at 3, 5, right? So the P point is 3, 5. And here is R is 4, 16. And trying to find the shaded area or shaded region between P, Q, R. So here we can just consider like the upper bound here is for the curve PR, right? And for the lower bound is the line or the very small segment is PQ. So just using the rules, like here is from 3 to 4, and is x squared minus 4, that is the upper bound of the shaded region, right? Then minus the lower bound, that is PQ, so it's minus 4. Sorry, minus 5, right? dx, so it can be considered as 3 to 4, x squared minus 9 dx. So that is for 1 cube, 1 over 3, x cubed minus 9x from 4 to 3. Then we just put 4 and 3 into it. So that becomes into 3. And here is for 64, and minus 4 times 9 is 36. And then we have to minus the like 27 over 3 minus 27, right? Okay, that is it. So first, 64 over 3 minus 27 over 3, that is for 37 over 3, right? And minus 36 plus 27 is minus 9, right? So after calculating, you find the shaded area is 10 over 3 units, okay? So that is how we exactly calculate the shaded region here. Just using the integration, using the upper bound minus the lower bound, okay? That is it. Okay, so we can make a summary here that if here we want to calculate the region between the two curves, here's y1, here's y upper and y lower, just using integration from x1 to x2, and the y upper minus y lower, then dx. We can calculate the area between them, right? Okay, that is it. So this for today's our lesson. Hope you can truly understanding for the integration rules between the areas. Okay, so that's for today's our lesson. See you next time. Bye.